shocked. You'd be shocked to hear where this all started from. You'd be shocked.
Yes, Tora, you'd be shocked, man. You'd be shocked. You'd be shocked.
Shock Tarts are my favorite candy. They discontinued them though. Shock Tarts. I freaking love Shock
Yeah,
Tarts.
We're doing
more
shockers,
shocking than
bro.
that candy, bro. It'd be super
2 in the
shocked.
pink, 1 in the stink.
Okay, let's try to get back on track. I think this is the 4th time I've asked this, and nobody seems to want to tackle this. Motion.
Just one comment, because there was the idea of using accelerometers. Accelerometers are not detecting motion; they are detecting change in motion, so acceleration. And an accelerometer could even detect acceleration without changing the position if you move a heavy object, like a lot of mass close to it or passing it. So you cannot use accelerometers to detect motion, actually.
Well, you said they detect a change in motion, so therefore, if you put it on something and it reads something, then the thing is in motion or not?
Yeah, they are working. Accelerometers are typically working with inertia. So if you move the outer housing of that accelerometer and the inner test mass has then an inertia and is kind of avoiding that motion, you see a change of position of the test mass compared to the outer housing, and that is measurable. That is, by the way, sometimes measured optically. So there are also accelerometers that measuring optically the actual change in position of the test mass compared to its housing.
Well, that cleared everything up. Thanks for that. It's almost as bad as SEACT. Oh my god.
I can't get an answer, right? What's going on, Andy?
Like if you move, what, I don't know that guy's name. Is it Snooze or something like that? I don't know. Snooze. Yes. If you move something, is it accelerating? Does that come under the category of accelerated?
If it's not moving before and then you start moving it, then yes. But if you just say you're moving something that, for example, I'm moving right now. I'm moving like with 55 kilometers per hour, but I would not detect that motion as acceleration, only if I change my velocity. That can be detected.
Jeremy's moving, but that's only due to gentrification, so I don't know if that counts. But
I mean, you said that if we had accelerometers detect motion, but then you could have an accelerometer on something and get a reading without the thing moving from other things happening, right?
I said that due to mass attracting mass or whatever, the accelerometer would be affected by a big mass passing it without the actual accelerometer being moved or the outer housing being moved.
Like if you blow
hold on, Tora, real quick. So you said the accelerometer measures movement, acceleration, but you could have the accelerometer give you a reading without the thing even moving.
Yeah, like if you blow compressed air onto it.
Is that right? Or hold on, is that right?
Sorry, I was just distracted. Can you repeat that?
Jesus Christ. Go ahead, Tora.
Well, I mean, does an accelerometer, if you like blow, compressed air onto it, like really strong, like say if I blew 200 psi of nitrogen onto an accelerometer, would that affect the reading?
No, if it's not moving, why should it?
Well, from my understanding, accelerometer is 2 plates with a spring in between it, no?
They are typically housed. So you have an housing and then you have a kind of spring-loaded test mass in the middle. So this is a closed system in that case. You cannot blow the test mass with air because otherwise it would be affected by these air movements.
Oh, it happens on my cell phone.
Do you think it'd be more accurate then to say, Snooze, that an accelerometer detects force? I know you don't like that word, Babooner, but just let go with it. Do you think that would be more accurate to say, right?
You could say it like this, even if it's not really accurate, but yes, yeah.
Well, then we have to break down what force is, don't we?
A
I
force
mean,
of
it's
a force.
measuring change in velocity due to inertia. So that's what an accelerometer is doing.
There's a
And
good side and a bad side.
You got to
Ohmic
define
force
the
out of
word
force.
force.
Yep. Force here, force there, everywhere a force. Ohmic force out of force.
Exactly. What's a force?
A force of what, by what, and to what? Can you answer that, Snooze? Been
What's
waiting
the
for that.
force? Of course. Nogan is looking for a force, of course.
I didn't claim that it's measuring force. I said you could, if you're not accurate, claim it like that. I did not bring in force, so don't try to strawman me.
Of course it's a force. Or is it a horse? Anyway.
It's not a force, of course. It's gravitation.
Well, it's 1 horsepower, of course.
I like to eat green eggs and ham on my horse while doing the force.
No, but this is not really complicated, right? If you can agree on a term, right? It's not really complicated. You have an object, right? Look around you, you have a table, right? It's there. You go and you push it, you move it, right? You want to call that a force? Call that a force. Why argue about words, right? Why not just talk about the physics?
It's
Right?
like an input of energy, right? Is that what a force is, or what would you call it? What would you describe it as, SE?
I guess you can call it you're dispensing energy. You
It's
can
the
go to
aftermath.
you ate and it converted. You can go on to all these complications, right? But why not just define terms and talk about the subject? Right?
A force is the aftermath of energy dissipation. It's an action, right? It's not a thing of itself. It's the action of something. And the something is what is in contention, but the mainstream just wants to focus on the action done and act as if it's all well understood.
Yeah, if you want to define force by
acceleration.
Sorry, go ahead. I think I clipped you there.
No, I said classically a force is just, it's defined as an influence that causes an acceleration, a change in speed or direction. Classically.
Influence of what? Influence of what? This is the question, right? We're trying to figure out a force of what, by what, and to what. So when you invoke a force, there has to be a prime mover. There has to be something that set that action into motion. It's not the quantification of the motion that we're interested in. It's the prima causa.
We're not even there yet, bro. This is what I'm trying to tell you. We have to define what we mean when we say the word force.
Dieslow, are you saying it's not a thing of itself? Like
Correct.
force is not? Okay, I got you.
I mean, force can be caused by anything, right? You have the 4 fundamental quote-unquote forces. There's other things that you have pressure forces, contact forces. Like
How
anything can cause it.
How many pseudo forces do you have in your model? Do you know the answer to that?
I don't even understand that question.
How many pseudo forces do you have in your model? How do you not understand the question? It was very clairvoyant. Open your ears.
All of them. Clairvoyant?
All of them. I'm looking for a number.
We have all the pseudo forces.
Let me repeat it. How many? I'm looking for a number. How many pseudo forces do you have in your model? I can give you the answer if you don't know it.
Oh, sure. Let's hear.
Infinite. It's infinite. This is how fucked off your model is.
Yeah, I don't know what you mean by that, but that's either true but irrelevant, or it's just not true.
It's very true. Get Zanuck in here. He'll tell you all about it.
Yeah, when you say our model, do you mean like the standard model, or like the globe model?
The standard model. I don't think we have to have a globe model when dealing with forces.
Sure.
Instead of arguing, why don't we just try to break down the action, right? Like, it's very simple. This is not rocket science. Can we agree on a rock, a big boulder on the ground? Can we all agree on this? An object that is not moving. Can we start with that? And I just have a couple of more follow-ups. 30 seconds.
I can agree with that.
What reference frame are we viewing the rock from, SE?
I'm gonna come over there and whack you one. I know you're doing it on purpose. No, but seriously, we got a rock on the ground, right? Okay, we can agree on this, right? Everybody. Okay. Now, can we define the term force, right, in this conversation as whatever it takes to displace that rock from its position? Can we start with that?
That's the force, yeah.
Okay, so how simple was that? Right? How simple was that?
Pretty simple. I think
I
you're the
don't
first
know. That
person
was
to
a
offer
pretty
an example.
complicated rock, bro.
That's
it.
It is simple.
Define terms and then proceed on to the conversation. We just agreed to terms right there, right? Now we know what a force is when we're talking about it.
But
how about that?
Bro, it is simple, but when you're talking about the use cases that they talk about, they're not going to use the same definition. It's going to switch. But
that's why you define terms before you start the conversation. That's the point I'm trying to make here.
Yeah,
I'm with you, bro. I'm with you.
In fairness, though, like that's a pretty simple example. There's other forces even in that example, right? Like friction, gravity, all of those things. Like depending on what exactly you're talking about, the forces in that example are going to be different.
I told you already, it's happened.
Well, yeah, you're going to try to complicate it as much as possible because not you in general. I mean, in general, the model believers, right? Like the last mass, for example, the last time we defined mass, we came up with how many definitions? 12 or something?
Well, that depends what you're talking about. Yeah, that's kind of the point.
Sadly, it does actually ultimately get like hyper philosophical when you try to fucking define this shit, and that's just a sad part of it.
Yeah. So if I'm talking giraffes and you're talking ants, well, what are we doing?
Well, you have a really unintelligent mark for the different things and imagining that they aren't clear.
Well, no, the problem is when we try to generalize from specifics, right? So if we're talking about a rock on the ground, that's going to be pretty clear what we're talking about in terms of forces involved in that scenario. Then you start talking about like things in fluid dynamic situations bumping into each other, that gets a whole lot more complicated. We can't take the same language that we use for the rock and apply it the same way. We're going to run into issues.
Well, in some ways you can, and if you think about it like clearly, right? Because if you equate you pushing the rock to make it move, right, then any other kind of explanation for that falls into, shall I say it, pseudoscience, right? Bending and warping of space-time and stuff like that.
I have a way in which the conversation actually could be done reasonably without actually getting into debates about the words too much, but I don't think anyone would adopt it. Basically, you treat the conversation as if you're in a video game and you're trying to discover the rules of the video game. That's all. And that is just simple. What will happen if X? What will happen if Y in the game?
Yeah, but bro, my point is if you don't come to terms with the definitions of the words you're using, the conversation will not go anywhere.
I'm with you. That was one of the points I was making in the beginning with the whole delta thing, right? But I'm saying if that can't be done, then another possible way of doing it, moving it forward, is to like think about this. Instead of thinking about things as quote unquote physics, just think about it as rules in a video game. What are the rules of the video game?
I mean, in fairness, most physicists are more than happy to do that, but very often I find, at least in these conversations,
I don't think this is a what question, though, Boomer.
Generalizing things.
Sorry, I didn't mean to cut you off. You're coming in real low, dude. I didn't even hear you in the beginning.
Yeah, low and fuzzy, bro. Yeah.
But Babooner, I don't think it's a what question. I think it's a what, more of a why.
like if the why question ultimately, like if that's why I'm bringing up the video game, like the thought, like the framework, because at some point with reality and with the video game, you're going to get to a point where you reach what we call like a brute fact, where something just is the way it is, right? From there, you can, go into the religious or spiritual foundation for whatever that brute fact is. Like when I say brute fact, all I mean is, how physicists say at the ultimate level, there's going to be some constants, and those are going to have some numerical value. Well, those constants would be the brute facts I'm talking about. So why? And then if you ask, like, why that value? Why does whatever? Let's say there is some ultimate form of gravity. Why that constant? No one's going to have an answer. Like everyone's going to, like, no one's going to have an answer where it's going to be beyond, well, that's just the way it is, or someone's going to say God did it, whatever. But there's going to be some like specific fact at the bottom level, which you can't go any further.
Yeah, but there's a lot of.
Why would you go on to explain reality through a fake world?
Oh my God, bro! Like, can people please?
Oh, my logic.
See, when people take gravity, for example, right? There's misconceptions out there. This is what I say. You have to come to terms when you speak to, and of course, in a debate forum for sure. But now I forgot what I wanted to say. For crying out loud!
It'll come to you, bro.
It was likely my fault.
I think you were talking about defining terms before having a conversation. So you said, when people.
Oh yeah. Thank you. Like for example, when people talk about gravity, right? I bet you, more often than not, even ballers, even flat earthers, even myself sometimes, when I think of gravity, like magnetism comes to mind, that kind of attraction. Yeah. Am I right?
Yeah.
Yeah, so it works to not think in terms of a video game, because the video game is not real.
God.
It's loaded, framed, and rendered.
Everything I say, literally, this guy just.
Why are you cutting me off?
Every single thing I say, dude.
Guys, what's going on, man? I thought you guys were like black hole of philosophy brothers and stuff.
Bro,
you guys were
no.
No, we're doing tag team poetry. They're on stage together. Go ahead.
Dieslow, that's not actual moderation when you just like mock people, even if they don't like communicate in a way that you think is productive. That's not productive either.
Yeah, correct.
Bro, what I said
all the time.
What I said was pretty simple though. Like it's not at all poetry. I just said, like, no matter what worldview you have, if you're talking about like the quantifiable aspect of reality, forces, motion, blah 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 blah, at some point you're gonna reach a brute fact. Does anyone can someone steel man what that is? A brute fact? I bet Gal.
Yeah, it's isness of reality.
Not you. Anyone other than you.
I can't steel man your position, meaning I'm on your side.
I would love anyone other than you to do it.
So
it would just be like some specific fact, like a constant of gravity, or physics, blah blah blah, and then asking why beyond that point, because this was in response to Dieslow. Asking why beyond
intellectual dishonesty, every other than you.
Anyone else? Can someone steal man what I mean by brute fact? Anyone other than
you? Sure, needs selective breeding in this
by virtue of being true.
Yeah, maybe Manufactotum could do it. I think he probably could do it. Yeah. Go ahead, Manufactotum.
Yeah, it's just something that's true by virtue of being true. Like self-evident, sometimes people say, but I don't know if that's quite.
No. I'm distinguishing that from self-evident facts would be like the laws of logic, where they truly are self-justifying. But let's say you have some constant of gravity, and it's like whatever 0.56734. Someone asks, well, why is it that? Why is it that number?
I'm glad you're not the moderator, so I can address
it. Won't be self-evident as like A is equal to A, but it will just be a brute fact. You won't. That actually in their system there will be no going further than that. That's what I mean.
So, what is a true fact, Babooner?
No, I'm not talking to you, bro.
For the room then. You just said, gotta agree on the definition of terms.
Why do you only talk when I talk? You weren't talking all this time until I started speaking. When you started speaking, you have some sort of weird gripe against me, bro.
Nah, man, it's nothing personal. You don't need to make it personal either.
Well, someone go back and listen to the recording. You weren't speaking the whole time.
No, I'm listening.
I guess didn't answer your question or worry, and that's really simple.
He's just trying to interact with somebody else. Maybe like let somebody else respond to his question and let him have a little back and forth, and you can try talking to him again. But you're kind of jamming up the chat here, Zenact. Pump the brakes. Oh boy.
Actually, he's jamming up the chat because he is.
Now you are, because the moderator has spoken and tried to moderate the situation, and you're just still trying to take it down that direction. Nobody cares about whatever it is that's happening right here. We just want to go back to the combo.
Yeah, so if people don't go into playing victim and we could have an actual intelligent conversation without dishonesty, then we wouldn't have this conversation.
Okay. Yeah, so manufacturer, do you see the difference between brute fact and self-evident fact?
Yeah, no, I get that.
Yeah, cool. Can you just steal my so that people know that separate me from certain other parties in terms of I'm actually saying something?
Sure. So a brute fact is just something that is, and something that's self-evident is evident. Well, something that's self-evident would be you could discern that from its, I don't want to say qualia, but you could discern that physically. Maybe not physically, but you could discern that. A brute fact just is, regardless of how we understand it to be.
Exactly. The self-evident fact would just be something which is necessarily the case, and you can just immediately perceive it to be as such. A is equal to A, blah, blah, blah. 1 plus 1 is equal to 2.
Yeah.
Whereas a brute fact will just be like some specific fact, and you could ask the question intelligibly, why that fact? It's just that the framework in question won't have an answer. So if they say, this is the fundamental equation of physics, like whatever, blah, 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 E is equal to mc squared. You ask, why that? Why not something else? Well, that's just it. Will be that answer, right? So every worldview is going to boil down to that. Something.
Yeah, I have a question. I thought you guys said you didn't want to talk about philosophy.
I know, but it had to go there ultimately. I had to go there.
And that was kind of the point of what Babooner said before, which is that these conversations tend to veer into philosophy every time because a lot of this stuff deals with, believing something without absolute proof.
Yeah, I was actually trying to steer clear of that, but I got sucked into that because I was just
yeah, that's what I was saying. Is that you point out look, a lot of this it tends to go into there.
Yeah, earlier on before you came, Galtrax, I was just they were having the conversation about motion, and obviously everyone disagrees as to which thing is in motion. So I was just trying to not go into philosophy and say can we at least agree that there's a delta between the two objects that's increasing or decreasing. And then
Yeah, but that difference will always be a philosophical bias. Either it's the stuff or it's the thing. Like the stuff that you're around you or the thing that you're on.
And the logic came.
Essentially, you're saying you're going to measure motion without knowing which one was moving?
Yeah, because both parties can't agree which thing is moving. So, okay, let's start with saying the delta is increasing or decreasing, because people invoke this term force, which I actually generally think is just a poorly defined term. And then that's where Effie said, give us the example about the boulder. And while we can all acknowledge that, what we're referring to as force in that example, I was saying that the moment you go into any of the physics that we're discussing, they will switch that definition or illustration.
So that both parties don't know, is that what you call the true fact?
Oh my God, bro. Why are you doing this, bro? Bro, can you just say something?
Why do you gotta play victim and can't just have an intellectual, honest conversation?
You're just doing the same. You don't talk until I talk, that's all. I was literally quiet again after the initial...
Because you're the one holding the stage and making, you're grabbing the mic and pushing it.
I was quiet for half an hour. You weren't responding to anybody else. The moment I spoke, you immediately spoke. You can go back. Anyone can go back and check those records.
Well, I because I haven't got a PhD, I'm, I don't know my arse from my elbow with this stuff. I like to see the definition there, just of his rock. Let's just keep it really simple. So that's why I said one thing pressing on another, right? I mean, you can't get more simple than that. And that's why I also said you can force and motion, they're interchangeable. You can just say motion, right? Because people hear this word force and it gets all convoluted, but it doesn't have to be, right? This is why I invoke the accelerometer, because when you push matter, when one thing presses on another. Right? The gases and liquids, for instance, change places. This happens every time. This is not philosophy. This is fact, physical fact. Right? So look at your bottle of water right now. Right? Where's the liquid? It's on the bottom. Where's the gases? It's on the top. It's very simple. It doesn't get any simpler than that, Babooner, does it?
Yeah. Dude, I'm with you, but do you not see the problem with saying force is equal to motion? When you then will refer to force when there is no motion, like a rock sitting on a table or on the ground, you'll say there's a force happening there, right? And yet there's no motion.
Yeah, we need a reason for direction. We need a reason why the vestibular system works as it does.
I know, so we're back to square one, because you said force and motion. It doesn't have to be complicated force, it's just interchangeable with motion. Well, clearly they're not, right? And clearly that's the question. That is the question here. Which thing is in motion? So,
Well,
but so I swear to God, it'll actually work. Instead of doing that though, just try and use like just try out using my video game framework. Just try and like reframe this as if we're in a video game. You'll actually be able to do it.
okay, let's see the video game thing.
No, you try and reframe your question within the framework of we're in a video game and you're trying to talk about how the objects in the video game are moving. Try and reframe your question within those parameters.
Sorry, I thought you already made some example I might have missed.
Your same example about like displacement, gas on the top, gas at the top, liquid at the bottom, blah blah blah.
Yeah, I mean that to me I don't need a video game. That's reality, right? I mean, this is where I say I haven't got a PhD, but I live in the world, so I can observe basic things, right?
No, I know you don't need it. It's just I'm saying that's just a conceptual filter, so that you can so that we don't have to get into philosophy, and you can just talk about things plainly. I'm actually like saying use that framework so that you don't have to, so we don't have to get lost in words.
Yeah, but I've already done that. I couldn't have explained it any simpler. To me, anyway, it seems very obvious that there's a constant happening on Earth, and I feel my weight, for instance, right? A simple trampoline. But what I was gonna sort of leading it to, what I wanted to talk about is that we do have this acceleration, apparently 9.8, right? And there's no force there. There's no force that can be measured. So on the one hand, we've got Newton saying, well, look, if something's accelerating, there needs to be a force present. And you probably agree with that, right? I would hope you'd agree with that. If something's accelerating, there'd be a force, because how else would it be? It's not going to accelerate through momentum.
Andy, he just kind of, I don't mean to interrupt you there, but he just kind of tried to negate that by saying a rock sitting on a table has force, right? And you agreed with that.
Well, a rock sitting on, everything needs direction, doesn't it? Everything needs, there's a reason why.
What force is involved when a rock is just sitting?
There's a constant on the Earth. This is apparent, right?
What constant?
Well, in the heliocentric model, they call it gravity. I'm happy to call it gravity.
Oh, okay. So we're back to Narnia. So we're not talking about reality?
Well, I mean, if you're going into the mechanisms of all that, that's actually quite interesting, because I think there was a bit of a scramble in the 1800s because they realized that there is an acceleration without a force. And if you think about it, if mass is attracting mass, that attraction, that would be an external force. That would be measurable. And it wasn't. Right? So we've got an issue here, because now we've got acceleration with no force. Don't you think that's interesting? That should blow your fucking mind. Right? Because why else would it be accelerated?
Measurable.
Yeah, but what
I'm saying?
I got lost, Andy. Can you? What are you saying again? One more
time. I'm saying that with Einstein's thing, right? There must have been a bit of a scramble when they were like, okay, we've got a force here, and our model says that mass attracts mass, right? And that would be measurable, wouldn't it?
What do you mean Einstein's thing?
Well, this is what I'm saying. Have you ever? You've looked into both models, right? Newton and Einstein.
Not really. No.
Well,
I'm familiar with the bending of space time as it was explained to me in like high school or whatever. And
this is basically why they say you can think of it.
Newton's mass attracting mass, right?
They say you can think of it as a force. By the way, your mic's a bit, I don't know, it's like scratchy.
Oh, hold on 1 second.
Yeah, it's choppy.
Well, that's not just me then, right?
Yeah, it was choppy.
Manufactotum, I know you know this shit, right?
I know a little bit of it, yeah.
Yeah, so we've got an acceleration with no force, right?
So gravity being a force, the way I like to explain it is that in 3 dimensions it's a force, and in 4 dimensions it's not. If we take the definition of force as being something that changes direction or speed, that's going to be a change in direction or speed in 3 dimensions, but in 4 dimensions it's like a straight line through curved space, so it's not a change in speed or direction. So it's not a force.
I quite like Jeremy's thing. That was quite funny. The Cavendish, right? So we've got the Cavendish. Mass attracts mass. Yes. So by Einstein then there would be no acceleration measured, right?
Better. Sorry.
In 4 dimensions, no. But the way that we're measuring the force, I don't think is by acceleration.
And there would be no acceleration measured, right?
Better. Sorry.
In 4 dimensions, no. But the way that we're measuring the force, I don't think is by acceleration. In Cavendish, we're measuring the tension on the wire.
So I'm a bit confused now, because if the Cavendish mass attracts mass, that should be picking up a very, very, very sensitive, incredibly sensitive accelerometer should measure any motion, really, right? So it should pick that up. But if it's working on the principle of it's in some kind of, pseudo-Romanian, all that shit, what they talk about, the fucking, what is it, the gravity well. If that's the cause of why it's happening, then there should be no measured acceleration at all, right?
Like, check, am I coming in now, Andy? Can you hear me pretty good?
Yeah, you sound better now, dude.
Much better, right? Just to address that question, like, I never really saw the point, right? It kind of was weird to me to hear other people really diving deep into those subjects, right? Those are all, it's all theoretical, right?
Kind of. I mean, I kind of agree that the main thing for me is that things fall at a constant rate. I think that's all I need, but people want to understand like the mechanics of it. I think that's also valid.
Why do you want to understand the mechanics of another man's thinking from long ago, when we already understand that everything that they've come to understand thus far is incorrect?
Really? That's a bold claim.
It is, and it's true, right? Look at the state of science and every branch of it, and how much actual progress has it made, and how much actual decent progress has it made, like doing anything for anybody.
Done a lot.
I mean, it's doing something for somebody, but it's a for-profit system. I can tell you right now, right? Our medical system over here is shutting down giving births, providing a place for people to give births because it's not profitable for them anymore. Right? So that's the state of your quote unquote professional sciences, and where their head is at. Just so you guys know, you sit here and you talk like this, but you don't actually. This was Zynak's problem. You're not actually talking about reality. I just wanted you guys to know that. Thank you.
Thanks for that.
Well, we are, because it's demonstrable. We can drop things. We do drop things a lot. So we're trying to figure out our world. There's nothing wrong with that. I mean, I would agree that there's a sort of limit. We are limited, and it can get a bit, I don't know. I think there is a limit to where we're like, okay, this is we're going a bit far and we're into Narnia. So I would agree with you to a certain extent. But then, what was it, that thing that Socrates said, something like, the unexamined life isn't worth living? So I definitely think it's good to understand the world around you, right? And yeah, I think if we're speaking about physics, we should just speak about physics, because, and I hear a few of you have said it ends up in philosophy and blah, blah, blah. Yeah, well, yeah, sometimes it does, but I just think of philosophy, and I think it just means the love of wisdom. That's how I think of philosophy. And there's nothing wrong with the love of wisdom. So, but if we can get back to the physics, manufactotum, we have an acceleration with no force. So this seems to be an issue. I would say it's definitely an issue for flat Earth.
Well, I would say that when you say there's an acceleration with no force, that's contradictory. Force is by definition an acceleration or causes an acceleration. So if you say there is an acceleration, then it sounds to me like you're in the realm of three-dimensional space. If you say that there's no force, no, if you say that there's a force but no acceleration, wait, I just confused myself.
Can we break down the fourth dimension? How do we get this fourth dimension? Can we demonstrate it?
No, you can't, bro. He's talking about space-time.
Yeah, well, I mean, space-time is just the relationship that space has with time. There's a sort of, I don't know, I don't think it's terribly magical exactly. I think it's just a way to talk about space and time as one four-dimensional thing. Kind of simplifies the equation.
So it's just conceptual then?
I wouldn't say just, but it is conceptual, yeah.
Well, they think that's reality. What they're positing is that that's reality. I don't know if manufactotum is doing that, but that's the conceit of relativity. That space and time are just one thing.
Yeah, I mean, the relationship that it has, that space has to time, kind of makes it so that we can talk about it as one thing. We can divvy it up the way we divvy up magnetism and electricity, but it's, you know, electromagnetism makes a lot of sense in many contexts to talk about it as one thing, right? I mean, we agree that space is a thing and time is a thing, right? Or no?
Yeah,
no,
separate things.
Does agree with that.
Yeah, I agree with it, but I think they're separate things, and I think that's the only way to have anything be intelligible.
Well, do you think that electricity and magnetism are two separate things?
Yeah, they may be. They may be. Go ahead, sorry.
No, go ahead.
But again, I probably shouldn't be in this discussion because this will go philosophical. Because yeah, whatever. I don't want to. I will bog this down.
I think I get where you're coming from. I think we can talk about them as two separate things. We can talk about them as one thing. What they are, with a capital A, might delve into philosophy, but I think ultimately it's how we structure the conversation.
I'll just say it one time. I won't get and break it down, but like electricity and magnetism are contingent things. Going back to the previous thing I was saying, whereas space and time are like fundamental semantic primitives that you can't break down any further. And when I say contingent, all I mean is specific. When I say semantic primitive, all I mean is something which you can't break down any further intelligibly. A concept which you can't break down any further intelligibly. Like change. You can't break down change any further intelligibly without invoking change. So that's a semantic primitive.
I see.
Or
I'm not sure I agree with that. I've had to think about it.
It's just like when people are making sense of anything, there are just some fundamental building blocks to meaning, like fundamental distinctions between categories, and those categories, if you break it down, they'll be unbreakdownable beyond a certain point. Like I could say length, breadth, and height. Those are all functions of some more fundamental thing called extension. And that's it. You can't break extension down any further. Or identity. Can you break down identity without using some variation of the word identity? You can't. So, space and time are of that nature. Whereas electromagnetism, what we're talking about is some mathematical relationships which are specific, which will break down into something more fundamental.
Sure.
Can
I get the distinction you're making.
Sorry, can you sort of? I realize the demonstration situation is a issue, and that's an issue for most people who, for me and as well, I'd put myself in that category. Flat earthers in particular, because they're going to want to see some kind of demonstration. But can you put space and time together in any useful? I mean, can you just sort of, I don't know, walk me through something where it's like, oh yeah, we put these fundamental things together, and then look at the brilliant, I don't know, utility sprung or something. I don't know.
Yeah, I can give you a sort of standard textbook walkthrough. So if you want to know the distance between two people, right, you have a Cartesian grid, an x and a y, and you can use the Pythagorean theorem to find the hypotenuse. Right, you go some distance over x, some distance over y, and that diagonal line you can calculate by those two variables. If you want to find someone in three-dimensional space, or the distance of two people in three-dimensional space, you do the same thing, but it's a squared plus b squared plus an x and a y, and you can use the.
And then look at the brilliant, I don't know, the utility sprung or something. I don't know.
Yeah, I can give you a sort of standard textbook walkthrough. So if you want to know the distance between two people, right, you have a Cartesian grid, an x and a y, and you can use the Pythagorean theorem to find the hypotenuse, right? You go some distance over x, some distance over y, and that diagonal line you can calculate by those two variables. If you want to find someone in three-dimensional space, or the distance of two people in three-dimensional space, you do the same thing, but it's a squared plus b squared plus c squared equals d squared. Did I get that right? Yes. If you want to find the distance between two events, you're going to have a fourth number, and that's going to be time. But time is going to be not perpendicular to those three, which are perpendicular to each other. It's going to be what some people call contradicular, which means it's a squared plus b squared plus c squared minus d squared equals e squared. So that relationship seems to hold whenever we measure it, and it seems to be the relationship that space has to time when considered as a fourth dimension. I don't know if any of that made sense.
Well, that's the first time I've heard contradicular. That's the first time I've heard that.
Yeah. Not my word, but I liked it, so I adopted it.
What was it again?
Contradicular.
Contricula?
As opposed to
like Count Dracula, but got it.
Yeah.
I like that too. It's pretty good. It's pretty ingenious.
How weak are we, like, or not we, how weak are the people in like higher education that when they're given a notion of space-time, how is it that they don't just laugh straight out at their teacher? And like how is it that we can be convinced of such an obvious error and keep going?
Well, if they're good teachers, they're going to explain it in a way that's apprehendable. Like they don't just throw you in head first in like, year one of physics. You kind of get the foundations first, and then if it makes sense according to the foundations, there's no real reason to laugh, I would say.
It's because they don't teach them the contradiction back to back. Early on, they'll tell you F equals ma.
Like they don't just throw you in head first in like, year one of physics. You kind of get the foundations first, and then if it makes sense according to the foundations, there's no real reason to laugh, I would say.
It's because they don't teach them the contradiction back to back. Early on, they'll tell you F equals ma. Then later on, they'll tell you, oh, there's the spinning of space-time and there's no force there. So they don't show them the contradiction back to back. You know what I'm saying?
Right. They slowly blend into one, and then they tell them you could convert it into this one. But still, how does an intelligent person, and let's face it, that you're not dumb if you're in university, right? How can you not fight back? How could the system have allowed this? Like, I don't get it, bro. It just boggles my mind.
Well, the answer might just be because the math works, right? So if they're taught something and then they're taught something different later on, they say this is a sort of upgraded model or the better calculation for it, and the math bears it out, say F equals MA worked for this, this, and that. Then they ran into a problem, and they came up with this one that works a little better. And now it explains not just the things we explained with F equals MA, but explains this new area of stuff as well. I mean, I would accept that, right?
No, it doesn't make sense. The only thing that I can think of is the people there know it's nonsense, like fabric of space and time. I'm sure, but they want to get their degree. They want to advance. They have to play the game, right? And it's such a pity, man, that smart people have to play dumb in order for this thing called science education that we have. It's a pity, man.
Yeah, I
Why
agree.
wouldn't they, after they don't have to, once they've gotten their degree, right? Why wouldn't they go get a job, get like a research position, and then just show them why it's all bullshit? Like, why not? Where's all the slew of people coming out saying, none of it was right at all? Like, most people come out with new ideas. They say, yeah, but we're still keeping this, this, that, and the other. Here's like a new.
Well, that part is easy.
That
part is easy because he's gonna get his degree, right, in physics, and he's gonna go work, or chemical. He's gonna go work for DuPont. He's gonna be making like $500,000 a year. That's why. Why is he gonna rock the system?
To be fair, even in the mainstream.
What about the guy who's got tenure?
No, but people do. People in the mainstream, people do just reject relativity completely. In fact, the going thing is that it isn't. Like, it's not fundamental, that it doesn't work. And that, we have to give a place and blah, blah, blah. And he furthered the field of physics.
Well, we've got to be careful, though. Sure. So if they don't say that it doesn't work, though, right? They say it doesn't explain everything. So we're going to keep what does work. We're going to add something. Like right now, they're trying to combine gravitational theory with quantum mechanics to greater or lesser degree of success, but they're not throwing the whole thing out.
So they're saying it mathematically works for some use case, but they're saying it doesn't work that's even in the mainstream. They say it doesn't work in the broader construct of there.
Well, it has the ability to work, though, right? So we could just call it energy or something, right?
Well, the thing is, the math doesn't even work because if you have zero force, and then you have mass accelerating, and you plug F equals ma in and do the math, you're not going to come up with any. It doesn't work. The math doesn't work. I know somebody said earlier the math does work, but it absolutely does not work with GR and F equals ma.
It works in a lot of cases.
In no cases, it doesn't work ever when things are falling because you have zero force there. And if you plug F equals ma with 0 as the F, it doesn't work. Never works. Not sometimes, not a little bit, never works.
Yeah, that's not what that means.
Yeah, they don't use. They say
the
they have
notion that there's. Sorry, go ahead.
No, you go ahead.
No, the fact that there's quote unquote no force there doesn't mean you plug 0 into F. That's not what that means.
Yeah, no, that's exactly what it means because you have mass accelerating. So according to Newton, you need a force. And if you plug 0 into the F, which is exactly what you would do there because we're looking for the force and GR says it's 0, the math doesn't work.
GR doesn't say F is 0. GR simply doesn't have an F term.
GR does say F is 0. There is no force there. That's 0. No force is 0. If you have nothing, it's 0. I know.
No, there is no force means there is no F in GR, right? But if you take the mass and the acceleration, you can get a force even using GR.
Nope, there is no force there. It's been blatantly told to us by many top-level PhD physicists, and there just is no force there. It's 0.
I think you misunderstand what they're saying.
No, I don't misunderstand jack shit. Fuck off with all the bullshit. Not interested in your games.
Back to this, are we?
Whoa.
Go argue if GR is a force somewhere else. We already know there's 0 force there.
There's 0 force, but it's not that force equals 0. Those are two different things.
Yeah, there's no force. That means 0. No force. If you have nothing, you have 0.
There is no force is not the same as the force equals 0.
That is exactly
I don't
what
know how else
having
to
nothing
explain it.
means. If you have nothing, you have zero. Like I said, I'm not interested in the stupid fucking word games. What does that guy always say? He plays
I see
stupid
that.
games, wins stupid prizes. I'm not interested in any stupid prizes.
Unless you got 30 cents a day to offer, dude. Yeah, I don't want to hear about it. All right, let's get back to a more productive conversation.
Yes, please.
So what about Einstein later in 1920 potentially readopting the idea of an ether? Or maybe you guys have another topic?
Yeah, Einstein did. He talked about it. So did Sir Isaac Newton in his letters to Bentley. So yeah, I mean, it was definitely on the forefront of their minds. You know, they couldn't just easily dismiss it. That was productive, huh?
Yeah. No
Who were we
comment.
being productive for again?
Pardon me, Dieslow?
No, I don't know. I'm just talking to myself. I got critique about non-productive ability or
You
something.
gotta get that checked out, dude. We told you about that.
I'm just trying to figure out who are we being productive for? I don't know. Just trying to figure it out, man.
For the good Lord.
Hallelujah.
Amen.